Hi there, this is the RPS project. I'm Richard, and today, well, it's more transistor biasing. I feel like I've been stuck on this for quite some time, but I really do need to understand what I'm doing with this transistor, especially in this Class A amplifier circuit. I've got loads of data now, so what I need to do is have a look at this data, maybe have a look at some equations and see if I can properly understand what I'm doing. So here's the data. I've been collecting quite a bit of data from testing with the transistor in a Class A amplifier type circuit. Been mainly using this particular setup with the biasing resistors being a 4K7 and a 2K2 with a 1K resistor on the collector. And the three that I've been mainly looking at in this scenario is the 1K 430 ohm 260 ohm resistor on the emitter. And there is quite a lot of data here, but is this data going to be getting away? Is it too much? Am I going to lose sight of what I'm looking for? So anyway, let's look at the first scenario of data that I collected with my ammeters being placed at the top of the resistor divider and being placed above the collector resistor. So this is the sort of data I've got from this particular setup. Ammeter here and ammeter here, top of the resistor divider, above the collector resistor. Now, as you can see, the base collector all seem to be quite high and it's all the same. That's because I am looking at it at the top of the resistor divider, which means I'm looking at all the current going through there, not just the current on the base. Whereas on the current for the collector emitter is showing all the current going through that transistor. But in my second setup that I did, you can see that the base current is a lot lower because I decided to put the ammeter actually at the base, and the ammeter for the collector I put actually at the collector, like this. Now I have the ammeter actually on the collector and the second ammeter on the actual base. Now you can see that the data is a bit different. The collector current isn't too dissimilar, it's about the same. There are variances, but then it was a slightly different setup. But overall there wasn't that bad or that much of a variance. But the base current has changed significantly. As you can see over here, it's 722 microamps with the 1K as the emitter resistor. But on the second setup, I've got 3 microamps because I'm looking at the current directly on the base rather than across the whole resistor divider. And with this scenario, I have found that the 430 ohm is probably about the best setup because I'm getting 7 microamps on the base and 2.2 milliamps of current through the transistor on that collector point. Now when I look at the voltages as well, this seems to be shown as being about right for biasing this transistor, which by the way was a BC337. I've got 2 volts on the base with the resistor divider that I've stated, 4K7 and 2K2. The collector voltage is 3.1 and the emitter voltage is 1.2, so I'm dropping 2.3 volts across that transistor. Now this to me seems quite good because the swing between 5 volts, which is my supply, and the 1.2 volts I'm getting on the emitter means that my collector is sitting at 3.1 volts. So I've got quite a bit of swing there, or should have, for any signal that's on there. So I suppose even this doesn't look like a great deal, 7 microamps, 2.2 milliamps, to me it actually is. It would be really good as a preamp a first stage amplification in a Class A amplifier, gives me something to work with in the rest of the circuit, rather than the really small 7 microamps that might be there, especially if the signal's really small on top of that. So that to me seems to work the best. There are a couple of equations that I want to look at, so let's have a look at those and see if they give me anything when it shows the relationship of this current on the base to the current on the collector with regards to gain. Okay, so I'm going to have a look at the gain, supposedly. A couple of equations I want to go over. First of all, I'm going to give a quick mention to, I don't know if his name's Paul, I keep thinking it's Paul, or is it John? I'm not sure, I always forget. It just sounds a bit mad, that, but he's got his own YouTube channel, W2AEW. This guy's knowledge is unbound. He's been really helpful. A lot of the stuff I found out is by looking at his website, his YouTube channel, and been very, very helpful. So that's why I'm giving a shout out to him. I'll see if I can put a link to his channel in the description. I say a couple of equations. First one is, I presume that means amplitude voltage, being it's basically a relationship between the collector resistor and the emitter resistor. So in my situation, I've got 1k divided by 430 ohm, and that gives me 2.32. Now, what does that mean? Is that the gain from 0.7 to 3.1? I don't know, because obviously on the collector, on the base, it only needs 0.7 of a volt for it to turn on the junction, regardless of what I put across there, even though I put 2 volts on there. So, but I mean, what's that? 0.7 times by 2.32 gives me 1.6, and I've actually not got that at all, so I'm not quite sure what that means. Second one is, for the gain, is voltage across the collector resistor divided by this VT, which I believe is thermal voltage, of which from the information I've read is basically saying that equals 26 milliamps at room temperature. So that's what I'm going to go with. I'll just take it as read that that's what it is. So I've got 1.9 volts divided by 26 milliamps, and in this occasion 1.9 divided by 0.26 gives me 73, and that equation is if I put a bypass capacitor across the emitter resistor. But again, what is that showing me? What am I gaining? 73 watts? Is that the gain but from the base voltage or the base current? Or it shows that I'm getting gain, which is great. I don't really understand what that gain relates to. Again, unfortunately, I don't have the equipment to show that properly. Something else I wanted to have a quick look at was the gain if I just looked at what I had the current on the base, and I had 7 microamps on the base and 2.22 milliamps on the collector. So that's the base and that's the collector current. I suppose the easiest way to do that is just to divide the collector by the base, and that should tell me how much larger that is than that. So I presume that again is gain, and that is current, so that's 0.0222 divided by the 7 microamps is 317, is that right? Let me just do that again, make sure. I've got 2.22 milliamps divided by the 7 microamps, 317. Yeah, so the gain is saying that I've got it's 317. Is that the beta? Again, I'm seeing these equations. They're giving me data and information, but I'm not really understanding how that relates to the circuit that I've got. I can see that I've biased it nicely with that's what 3.1 volts on the collector, but I suppose without the equipment like an oscilloscope and an accurate function generator, I'm not really going to understand what this is doing. I just have to accept that I've biased the transistor up and it should give me some signal out, not quite sure what, and I can use that as a preamplifier in a circuit. If I really wanted to get technical, I think I'd have to find a way of getting some more equipment, but there you go. So there you have it, some data on transistor biasing. A couple of equations on trying to calculate gain, me working out the gain from the current I got from the data, and really not feeling a great deal closer to understanding what's going on. I suppose I'm just have to live with what I've got and know that I feel like I biased the transistor up adequately, put it in a circuit and try out that circuit and see how it works as a first stage preamp for something else, for another part of a circuit, for a bigger circuit, and I'll just have to try it out and see what happens. But I feel confident it's going to work. I just don't have the equipment to really see it in detail. Anyway, if you like this video, give me a thumbs up, subscribe, and all comments are welcome. See you next time.